In this video, we'll generate the binomial series Pascal triangle coefficients to the fourth degree. We'll use the combina, combine, and permute in the Taylor-Maclaurin series sum of the Pascal triangle binomial series Pascal triangle coefficient. So we begin with the 1 minus x to the power k. This will be r of the quantity 1 minus x raised to the power k, and the value of k. Data validation, list of items 0, 1, 2, 3, and 4. That's because we're calculating these coefficients. So that's 0 up to 4. And we continue with the 1 plus x to the power k. So array formula, the quantity 1 plus x raised to the power k. And we'll chart this. Insert chart. And we'll use scatter chart. So let's have a look how this is going to look like. So at k equals 0 and k equals 1, k equals 2, k equals 3, k equals 4. We'll show the equation and the polynomials. So this will be the series, trend line, polynomial. Try the highest degree. No, it does not work, so go lower and show the equation as label. Now we have the polynomials. And the legend use at the bottom. Position at the bottom. You have to clean this. We begin with the horizontal axis. The number format should be none. Now the vertical axis. Vertical axis, we show the axis line. And the number format, we have to change this. It would be none. Now that's better. So here we have the trend line for 1 minus x to the power k in blue. And this is 1 plus x to the power k in red, but that will change once we add the expansion. Next, we continue with the Taylor-Maclaurin series sum expansion, which is the summation of a times x to the power n, where a can be combina, combine, or permute. And n is from 0 to infinity. So we can go as far as 8. 8 is good enough for infinity. So, and we now continue with the coefficient permute. So this is equal to array formula c to the power n. So c, we have no value of c here yet, raised to the power n times permute k comma n. So k comma n. That's the permute. That's the numerator. Now the denominator divided by factorial n. So factorial n. Now the value of c. We have no value of c, so data validation. List of items. -1 if it is for 1 minus x to the power k, the blue one. And +1 if it is 1 plus x to the power k, the green one. And save. So the value of C will be -1 or +1. They're all positive. If it's negative, there's an alternating sign. Now we have to clean this. So to do that, we have a condition that if n is greater than k, it should be 0. So if this is n, so the condition should be if if n is greater than k, which is this, and 0. Now it's clean. Now we continue with the combine function. This is equal to array formula c to the power n times combine k comma n. So k comma n. Then enter. Now we'll use the same from here up to here. We'll copy this, and copy it right here. Paste. Then enter. Now it's clean. They are the same. Their values are the same. We continue with the combine function. This is equal to array formula, that is c raised to the power n times combina. Combina, that is k minus m. So k minus n plus 1. So k minus n plus 1 plus 1 comma n. Then enter. So we still have the same problem. So what we can do is this portion from here, we'll copy this and paste it from here. That should be okay. Now they're all the same. Now we can calculate the expansion. So array formula, raised of x of series sum of the x values raised to the power n, where the value of n is starts from 0, incremented by 1. And the coefficient, there are 3 to choose from. Let's choose PERMUT, since they are just the same value. Now this is green, this is red. We have to change the color of the 1 minus x to the power k. So, data validation and series, trend line, polynomial to the 8th degree. Use the equation as label. Now we have all the labels. And we change the yellow to green. So to green, change this to green. Now this matches to our data set. And now to distinguish the red, because red will move from blue to green, so change this expansion. There will be no points. First, we have to change to O series. The maximum point size will be 14. Let's put it that big. But in the case of the expansion, the point size will be none. That's for the expansion. But the line thickness will be maximum. So if we change this to positive 1, the red approximates the green. If we change this to negative 1, the red approximates the blue. Now we calculate the polynomial regression coefficients using Linest. Let's prepare the Linest matrix. This will be transpose 0 to 8. And the elements of the Linus matrix. So array formula of the x values raised to the power 0 to 8. Now we can calculate Linus starting with the 1 minus x data set. Linus data y and data x. And the expansion. So Linus data y and data x. And the 1 plus x to the power k. So Linus data y and data x. And enter. So let's compare. At c equals 1, the red, the expansion approximates the 1 plus x to the power k. And their coefficients are the same. So we have 1, 4, 6, 4, 1. So for x to the 0, that's 1. For x, the coefficient of x, 4. Well, this one is minus 4. The coefficient of x squared, 6. 6, 6, 6. The coefficient of x cubed, minus 4, positive 4, positive 4. Minus 4, positive 4. The coefficient of x to the fourth, 1. That's 1, 1, and 1. If we change this to negative 1, so the coefficient will be 1 for x to the 0. For x, negative 4, negative 4, 4. X squared, 6, 6, and 6. X cubed, minus 4, minus 4, 4. X to the fourth, 1, 1, 1. So, suppose I change this to 0. So these are the polynomials. Change this to 1. These are the polynomials. Increase it. Although these values are 0, that's 3 times 10 to the minus 14. 10 to the minus 16, that's 0. 10 to the minus 14, these are 0. So that's why they're all 0 here. Even this one is 10 to the minus 16, there's 0. K equals 2. We can change it to 1. K equals 3. We can change this to minus 1. K equals 4. We can change this to positive 1. Suppose I change the coefficient. Instead of permute, I'll use the combine. So remove this and use the combine. Enter. I still get the same values. Let's start from 0. Change this to negative. Nothing changed. Then k equals 1. Change it to positive. K equals 2. Change this to negative. K equals 3. Change C to positive 1. And k equals 4.